Good morning, everyone, and welcome to the Breakfast Club. As most of you know, the Breakfast Club was formed following the 9/11 tragedy. We had put it together in order to help those that lost their jobs to the tragedy. And then over the years, different economic and financial circumstances, now, pandemics, have forced us to definitely keep the group going in order to help as many people as we can with job search and career management. Within the group, we're blessed to have a number of volunteers that help us with things like today's program, membership, planning, the speakers and the presentations, a lot of housekeeping items like uh, helping people join the group and manage their membership. So one of the things that I want to do is just go through very quickly how one becomes a member. If you go to thebreakfastclubnj.com, that is our website. Right on the home page, there is a join button. We are a Yahoo group for our communications. Our primary communications vehicle is through that. And to join, everything is free. All you have to do is provide your full name, your email, and your phone number. Again, your full name, your email, and your phone number. And then that puts you into the group. Through that email, that will be our primary communication vehicle to you. So if you have more than one email, you have to remember which one you joined with, because that's what will be in the Yahoo group and officially registered. And from that email that you joined, you can email everybody in the group by emailing it to thebreakfastclubnj@yahoogroupsplural.com. And that is very critical because any job search or career management communications you have for new members or members that, may fall back into transition, put out an elevator pitch in writing to everybody to introduce yourself to them. We have over 6,000 members. Within our 6,000 members, we have over 800 of them are sitting C-level executives, and many more are hiring managers. So by sharing with them a little about you, what your value proposition is, what you bring to the table, that is how you can open up opportunities. You should also be using that communication vehicle when you're targeting companies. Let's say I'm targeting XYZ company, put out an email to the entire group. Is there somebody that works there, has contacts there, used to work there, and then have them respond to you directly. And then once they do, take it offline and talk to them about that company, find out about its culture, about, how job titles work there, so that, you can, a lot of times you can parlay that maybe into a reference right into the hiring manager. So those are the things that are really going to help your job search and more so help your candidacy. So you're the one that networks around the rest of the candidates that are seeking the same job. A few days after you join the Yahoo group, our administrator, Haresh Kaswani, will then send out an invitation to join our LinkedIn group. Our LinkedIn group is actually a hidden group on LinkedIn. So if you just casually, go out and look for it, you won't find it. Once you're into the group, you accept the invite, and then you still have to connect to each of the other individuals in the group directly. But then you have the visibility of everybody who's in our group that's in our LinkedIn group. And these are people that are receptive to networking and helping others. So, it's a great way to grow your network very substantially and very quickly. Because the whole thought process of why we do social media and put all this in place is because we have a large amount of members in a small concentrated geography, basically between the tri-state area here of New York, New Jersey, and Philadelphia. The standard profile for our members is, most of our people have 20 years of work experience. So within that 20 years, many of them have multiple employers. So when you have that concentrated geography of a lot of professionals with 20 years of history, the thought process is it should be a high probability of being able to find somebody that knows somebody at the targeted company, works there now, or used to work there. And that's what it's all about, is networking is the biggest way that you're going to find your next job. And that's why we use social media so extensively in order to try and help that happen. Adrian Roman, who is our administrator for Meetup, also is an administrator for our Facebook group. So you could join our Facebook group as well. The benefit of joining the Facebook group is, as you're trying to network with people, there's 5 times as many people on Facebook as there are on LinkedIn. So if you're trying to connect with former workers, colleagues, people that you went to school with, etc., you should have a much higher probability of success of finding them on Facebook than you do on LinkedIn. The reason we have a Meetup group is we had a Meetup a couple of years ago. It's been very successful for us. In just the short time that we added it, we have over 3,000 of our members that are on Meetup. Meetup takes the guesswork out of when our meetings are. Our meetings are always the second Saturday of every month at the same time, and now via video conference, but normally the same physical location as well. And this is just a little reminder that it'll send you out a reminder when the meeting is. You can RSVP, and then the meeting will further remind you that it took place. But the biggest advantage I see to Meetup is the networking capabilities. So if you RSVP'd after the meeting takes place, it sends you back a confirmation of all the people that met, and you can go through that list. And if you remember a face and not a name, or a name and not a face, it helps you find that person, so that if they said something, or if they work for a company you're interested in, or you want to network with them further for whatever reason, it helps you in identifying who that person was, if by chance you didn't capture the person's full information. The Breakfast Club is here to help you, but again, leverage it to the greatest extent possible. I'll have a lot of people that will contact me and say, "Hey, Frank, do you know anybody at XYZ company?" And I was like, why would you want to just ask me instead of 6,000 members by simply sending one email? And I'm always astounded where, either a new member or somebody who is existing is back in job search, and they haven't put out the simple message of their elevator pitch to all the members. Because, then I'll casually meet with someone else, and they'll say, I'll say, "Oh, did you know so-and-so's out?" And they'll say, "Oh, really? I could have helped them. I have a job that, they'd probably be great for." But they don't have the knowledge or the visibility that the person's out. So really use the network, our group, all of our social media communication channels to your advantage. We should see so many messages flying around out there on the Yahoo groups and everything. The only thing, again, that I must stress is it has to be job search or career management related, and we don't permit members to solicit, business from other members. That's the only limitation. So if you see new things on, like last night, the president put out new information on extending unemployment benefits, something like that, put it out there. If you have job recs that a recruiter is looking for, it's a great way to, number one, establish a stronger relationship with the recruiter, and to help your fellow Breakfast Club members by, practicing good citizenship of sharing leads with them. So to expand on that, let's say I'm calling a recruiter all the time asking them to help me in my job search. We'll turn it around and say, I belong to this group. It's the Breakfast Club. There's over 6,000 people in it. Do you have any job recs that you're having a hard time filling? Say, if you'd like, you could share them with me. I'll post them on the Breakfast Club for you. Now, if that recruiter, as a result, gets a great candidate and winds up placing them, you just help that recruiter make money. The next time you call them up and you ask them to help you out, they're going to be very receptive to taking your call. They're going to want to help you. So it's a way for a win-win-win all around for the recruiter, for you, and fellow members of the Breakfast Club. So, try and think in those veins. You're not only in job search by yourself anymore, you're in it with 6,000 people. You've got a strong network behind you. Connect to as many of them as you can, and then leverage the network to your own job search's benefit, and really let it help you be successful in your job search. So with that, I'm going to turn it over to Jerry Payton. Jerry and David, as we said, are two of the individuals that lead our speaker and our presentation committee. And, they go out there and identify different speakers and topics that they feel will be very good for our membership. With that, I'm going to turn it over to Jerry. Jerry will introduce today's presentation and speaker, and I hope you enjoy the program and just follow, the housekeeping tips that David has shared at the beginning. Thank you very much, everyone.
Thank you, Frank. Good morning, everyone. I wanted to just first give an overview of why we have blockchain on today, and that's because this is an important emerging technology that is fast growing throughout the industry, and one that you really need to have some knowledge about. And so today's goal would be to give you that initial introduction so you'll be aware of that as you're going through and doing any kind of interviews. Let me do the introduction to today's speaker now. Lindsley Medlin is an international executive with more than 30 years of experience building and running businesses. During his career, Mr. Medlin built companies in 6 countries. He was part of a management team that organically grew a business from 20 million to 1.5 billion in 9 years, which went public and spun off a separate public subsidiary. He holds a Bachelor's of Arts in Economics and an MBA in Marketing, both from Rutgers University. Additionally, he is a certified blockchain professional and is the founder of the New Jersey Blockchain Center. Mr. Medlin is a published author, speaker, and consultant. I'd now like to introduce Lindsley.
Thank you, and thank you for the opportunity to speak to the group. I haven't been there in a while, but it's nice to see some names and faces that of people that I've met throughout the last couple of years. So I'm going to speak on blockchain, and I've also tailored this for the Breakfast Club to include a section on blockchain in your career to help you guys understand a bit about how you might get involved in blockchain depending upon what your chosen path is, or if you are planning to maybe pivot in your career. So ask your questions in the chat, as David said. I'm happy to take questions, and I'm going to try to walk through this. You don't need to be a technologist. I'm going to give you just a little bit of technology to understand it. My objective is not that you guys are experts by the end of this by any means, but that you get enough of a foundation that you understand the concept and you get that light bulb moment, right? Where your brain tells you that, oh, okay, this makes sense. I really want to give you a foundation so that afterwards you feel comfortable reading articles, maybe reading more information in depth, or watching a video. So that's my goal, just to get you started. Okay. Very briefly, Jerry introduced me. In my past, I approached this from the role of like a COO. I'm not a technologist. I've never been a developer or a programmer, but I've worked with the technology as an operations professional, and that's kind of how I try to approach this this subject when I'm teaching it. Quick disclaimer, because blockchain and Bitcoin and cryptocurrencies are all related, I just want to make sure everybody understands I'm not making any investment advice regarding, you know, cryptocurrencies or financial investment, just providing educational content. So this is what we're going to cover. I'm going to tell you first why blockchain is important. Then I'll go through the blockchain in your career section. Then I'll take you through what is blockchain and how it works. And then we'll finish up by talking about a few use cases. Okay. First, I just want to make sure we're all clear on this concept of Bitcoin versus blockchain, because many of you, have heard of Bitcoin and associated with blockchain, and they are associated. The concept of blockchain really came into practice when Bitcoin launched, because Bitcoin used blockchain as a protocol to achieve the objectives that it was trying to achieve as a financial instrument. So they are related, but think of blockchain as the as the protocol or as the technology, if you wish, and Bitcoin is an application of that, the first killer app, really. But in a few of the slides where I have some people giving quotes, you can interchange those words, because sometimes somebody will refer to a quote about Bitcoin, but the same thing applies if you're thinking about blockchain. So why is blockchain important? I like to start with this slide. This is from the Harvard Business Review in May of 2016. And it's basically telling us that of all the technologies that we're aware of and we hear of and we read about, the one most likely to change the next decade of business is blockchain. And Blythe Masters, who was formerly was the CFO of JP Morgan Investment Bank and former CEO of Digital Asset Holdings, she said, you should be taking this technology as seriously as you should have been taking the development of the internet in the early 90s. Accenture has said that blockchain can really reduce costs for the big, the largest banks, and an average of 30% for 8 of the 10 largest banks in the world. And they're projecting that annual cost saving is $8 to $12 billion. So financially, this is something significant that the banking industry is looking at. Mark Andreessen, many of you know the name. Maybe you've heard of Andreessen Horowitz, the VC firm, but he first came to fame as the inventor of the first real commercial browser. He invented Netscape back in the day, for those of you that remember. And he said that Bitcoin and or blockchain gives us for the first time a way for an internet user to transfer a unique piece of digital property to another internet user, and that the transaction is guaranteed to be safe and secure. Everyone knows it's taken place. No one can challenge the legitimacy. And he said the consequences of this breakthrough are hard to overstate. Jack Dorsey, CEO of Twitter, said we're going to a world with this technology where all content that is created can last forever. You won't be able to take it down, you won't be able to censor it, and it won't be centralized. And I've got the irony alert sign up there because those are all things that Twitter does. So it's interesting that he's the one who made that comment. Bill Gates said Bitcoin is a technological tour de force. And then Leon Luau, a Nobel Peace Prize nominee, says every informed person needs to know about Bitcoin, i.e. blockchain, because it might be one of the world's most important developments. The CEO of Google also said it's a remarkable achievement. And the key here is, he says, the ability to create something that is not duplicable in the digital world has enormous value. And we'll talk about that and what that means. Some statistics here, predicted that 25% of global transaction banks will use blockchain. 10% of global GDP will be stored on blockchain. Estimated size of the blockchain technology market, 2.3 billion. Business value added by blockchain, 176 billion and growing to over 3 trillion. So the reason I share these is because I just want you to understand and have a frame of reference and a context about what's going on with this technology with regard to investment and development of solutions to implement. Kind of a fun slide. Alexander Graham Bell offered Western Union a telephone patent in 1876 for $100,000. And their response was, the idea of installing telephones in every city is idiotic. Why would any person want to use this ungainly and impractical device when he can send a messenger to the telegraph office and have a clear written message sent to any large city in the US? This telephone has too many shortcomings to be seriously considered as a means of communication. The device is inherently of no value to us. And I say that because anytime you have a breakthrough with a new technology or new invention, you're going to have people on both sides. So there are people who, don't really believe the impact of blockchain and Bitcoin. So what I'm going to tell you is, the early internet was clunky, wasn't very user friendly. Mostly, it was geeks and nerds who used the technology first, but eventually the technology evolved. And it's much the same with blockchain. Okay, we are in the early stages. It is still a bit clunky. It's not always user friendly. Most of the early people who started using it were definitely, the technology inclined, but it will evolve. So don't be afraid. And we all remember this, right? This is the analogy. If you remember back to the launch of the internet in the early 90s, most people didn't understand these words: download, bandwidth, website, modem, domain name. They were new in the lexicon. And if you had told somebody, go to http://, they'd look at you like you were speaking another language, right? And these are some examples of early web pages. They were not user friendly. They were not pretty. They didn't have a whole lot of functionality, but we've evolved from that. I will say I have a couple of videos in here, and we found that there's a technical issue with hearing the sound, so I'm just going to skip through those. So any questions at this point?
No questions posted yet. Remember, folks, if you have a question, please precede it with the word question and type it into the chat. We'll get to it as soon as we can.
Okay, great. Let's go forward. Now, blockchain in your career. As with most new developments and technologies, you want to have a basic understanding, right? You don't want to be this guy. What color do you want your blockchain? I think mauve has the most RAM. I mean, that makes absolutely no sense. You don't want to be this guy who sounds like you just read an article, but you don't understand the concepts, right? And you don't want to be throwing out terms and not be able to speak about them. So we're going to try to help you, be in the percentage of people that is more knowledgeable and can speak to these things. And hopefully from a job search perspective, that will help you separate yourself from the crowd. One of the vice presidents at Oracle last year said between 50 and 60% of companies will use blockchain in the next 3 years. Now, that's not saying their entire business is going to be transformed with blockchain, but there will be some use case of blockchain. And even if you think that he's overestimating, if that number were 25 to 30%, I think that's still significant enough that from a career perspective, you really want to have some understanding of this. Over the last few years, these are some of the headlines that we've seen. LinkedIn, blockchain developer was the #1 emerging job a year or two ago. Continues to be a strong job from a developer perspective, but it's moving beyond that, right? And over the past year or two, New York City has positioned itself, wants to be a hub for blockchain innovation, which, being in New York City's backyard, means that there's opportunities here for us. And New York City, has been hosting for the last couple of years, basically one of the largest blockchain conferences, and that's grown into Blockchain Week, where they have multiple conferences and meetings throughout. TechCrunch, back a few years ago, said that blockchain-related jobs were the second fastest growing in the labor market, and that there were roughly 14 job openings for every one blockchain developer. And again, this was related to people who could actually code and develop blockchain, but that tells you that there's projects going on and there's a growing ecosystem around it. But you don't have to be a developer. LinkedIn said that blockchain is the top skill for 2020. So again, they're still predicting a lot of job opportunities, in and around blockchain. So what are we talking about, right? What are some of the career paths in blockchain? Well, you can see on here, obviously, blockchain developer is something that is in high demand, but then you need other things around that. Quality engineers, experts who can help design and architect solutions, legal consultants who can understand the issues related to blockchain, engineers, project managers who can help build blockchain projects. And I know, in this group, we've got people who do a little bit of all of those things. This is a hard one to read, but this basically is saying there are different career paths for both technical and non-technical professionals, right? Obviously, if you're technical, you can learn some of the foundations of dealing with these solutions, but you could be a business leader in a non-technical role, helping to implement. You can be a project management. You can be a healthcare professional utilizing blockchain solutions, right? All of these things, cybersecurity professionals, all of these things. So you don't have to be a developer. If you're in supply chain, there are a lot of projects being built for supply chain systems to track, and we'll talk a little bit about these in the use cases, but there are a lot of opportunities. Supply chain, after the financial industry, supply chain is probably the second largest industry in terms of adoption and implementation of really building out these projects for blockchain. But government services is another area where governments are looking at ways to reduce costs and provide their services more efficiently. And if you have, a career in government, and now you can marry blockchain knowledge, that helps put you in a better position. Accounting and audit would be another strong area because of the way that blockchain is used as a ledger to track transactions. Marketing is as well. There's a lot of challenges in digital advertising in the marketing space, and there are blockchain solutions being developed to help make that process more transparent and reduce the fraud, so that as a brand, you can know that you're not wasting your marketing dollars on fraudulent activity just designed to run up the bill. Digital marketing, we just talked about that. Pharmaceutical, again, tied in with supply chain. If you think about the supply chain for pharmaceuticals and being able to utilize blockchain, most of the large pharmaceutical companies that we're familiar with are already working on blockchain projects. Hospitality. So you're talking about, travel and hotels and restaurants. Loyalty schemes like your rewards points, programs like that could be put on blockchain. Identity management, right? And also supply chain in those areas as well. insurance industry. You know, a lot of ways that that insurance can be improved so that some of the paperwork pushing and some of those things can be done utilizing blockchain programs. So banking, government, healthcare, we've talked about these. There is a lot of development going on. Every industry, right? Education, retail, energy, food, legal. So what I did was I went to LinkedIn and I pulled up blockchain just to give you guys a feel for some of the things that are out there. And they're not, as I said, they're not all developer related. Here is a director of operations for a cryptocurrency fund looking for a controller. I know we have people with those skills in our group. Customer success manager for a blockchain related company. I know we have people with those skill sets. Content strategy manager, director of business development, client relationship management team lead. So, you know, there's a little bit of something for everybody here. As I said, some industries are adopting it more rapidly than others, but does everybody understand that you don't have to be a developer to take advantage of what's going on in this market? Any questions yet, David?
Yep, we've got a few questions, so perfect time for a break. The first question is from, well, this person just identified as A. What problem do you think blockchain resolves? Is it just the lack of trust in central/organizing authority?
No, and I'm going to cover that, but really, it solves the problem of third parties being required to provide that trust in between two parties of a transaction. So if you think about a bank, right, you don't trust somebody else necessarily, but you trust the bank that they're going to keep the ledger for you and move the funds around. So that's clearly one of the issues, but in broad terms, it's really about creating digital uniqueness in a sense and being able to timestamp transactions so everybody can agree on what is the history of what has occurred. And we'll look at that as we go further through.
Okay. Ian asks, what are some other killer blockchain apps?
Well, clearly in finance, it's Bitcoin and cryptocurrency, which is the ability to transact financially between peer-to-peer without a bank in the middle. That has huge implications, and we'll talk about that a little bit more. Supply chain, as I said, is a big one. For the most part, the supply chain part is providing transparency in the goods and where they come from and where they are and how were they prepared or how were they harvested if you're looking at food. Decentralized finance and decentralized applications really are a way that we can transform the way the internet works to some degree. So you can control your information and your data, and instead of Facebook and Google using your data and reselling it for purposes of selling ads, you can control your data and effectively sell it to an advertiser in exchange for access. And you can do the same thing with healthcare. You can control your healthcare data and potentially sell it to researchers.
Okay, thanks. Judith asks, do you know if the state of New Jersey is using this technology to address the PPE and ventilator supply chain during the pandemic?
Not yet. As far as I know, not yet. The state of New Jersey has created a blockchain task force. Their mandate is to make some recommendations to the state, to the legislature about ways. Initially, their focus are ways to implement blockchain in state and local government for efficiency and cost reductions. They just really started that in 2019, and so they're not far enough along the way really to be talking specifically about PPE. But there are other people in various locations that are looking at it because they're trying to quickly apply this technology to those solutions.
Okay. Alex asks, if blockchain is so safe, then why isn't the technology used for voting?
There are pilot programs going on for blockchain with voting. They're still early on, they're still in beta and being tested. There are obviously a lot of other challenges, as with any new technology. The law has to catch up, regulation has to catch up, and it's not just the technological use of it, it's also the social, the cultural, the political. But there is a movement to try to utilize this technology to make voting more transparent and secure. I think we'll see more of that as we go on, but it's just not there yet. It's still in the early stages.
Okay. Bob asks, can blockchain be used to confirm the identity of an individual versus an AI or robot designed to mimic an individual in an online platform?
Yes. There is a very large movement around what we call digital identity, and that's being able to basically have your identity in a digital format that you can prove who you are. The UN had many of their agencies are using this because of the ability to track displaced peoples and deal with refugees, for example. In a nutshell, basically, it's a way to have your identity on a blockchain where you are the only one who controls access to it, and you can prove who you are and release as much or as little information about yourself as you want.
Okay, that's the questions for now. Let's move along.
Okay, great. So what is blockchain, right? I said before, it's the underlying technology platform that makes Bitcoin work as a digital currency, which was the first use case. And to do that, it solved a major problem, which is referred to as the double spend, right? And that really allows us to have digital uniqueness. And the double spend means that, if you send somebody this piece of value, like a Bitcoin, you have to be able to protect against somebody sending the same value to multiple people, okay? So, and that was the challenge for years in trying to develop a digital currency, is how do we make it unique? And Bitcoin solved that problem. So essentially, what was the problem? It was being able to timestamp, and provide the uniqueness for that digital data and have that recorded on a ledger. If you think about digital things like JPEG images, audio files, movie files, Word documents, when you send somebody one of these, you're actually sending them a copy. And then you can create multiple copies of the same document because it's in digital format, which works great if you want to share, a PDF file or a picture. But it doesn't work well if you're talking about money. And that was the challenge, and that's why we had to have some way to create digital uniqueness so the money couldn't be spent, couldn't be duplicated, couldn't be counterfeited. And that problem was solved with the design of how Bitcoin was released. And now it's being applied to these other industries. So you can think about it as a new technology and a new protocol, but many people are saying right now that up to this point, what we've had is an internet of information, right? It's basically been an exchange of information on the internet. You can go to websites, you can share information, you can send, books digitally back and forth, you can send emails. Blockchain now takes us to the next level, which is to create an internet of value. You can send value over the internet, unique value over the internet, financial value, right? Identity value, knowledge value of some sort. So it kind of takes the internet to the next level. All right, we're going to skip this video since we can't hear the audio. So blockchain is really, it's a unique combination of a lot of things that have existed before. So very strong connection to distributed ledger technology, right? Which is the concept of having, well, it's basically the internet, right? It's the concept of having a lot of computers connected together and figuring out how they communicate. It includes the use of cryptography, which has been around for, years and years and years, since, ancient times. And it also takes into play economic game theory, right? Economic game theory really just talks about how do we get a diverse group of people that are maybe spread out, all to act in the way that is best for the group. And so that comes into play in terms of designing a blockchain system. And all of these things that we've had in the past were kind of put together in a unique package to give us blockchain with the release of Bitcoin. At its core, okay, a blockchain is simply a shared accounting ledger. We pretty much all know what a ledger is. Ledgers have been around since the establishment of double entry accounting. But this shared accounting ledger uses a network of computers to track these assets, and it uses cryptography to secure the ledger from tampering, okay? And a distributed digital ledger that batches transactions into groups, and that's where the term blocks comes from. They are basically groups of a batch of transactions, and they are linked together, and that's where the chain part comes from, using cryptography, and that's how they're secured. And I'll show you so you can understand the concept, but that's essentially what a blockchain is. It's a distributed digital ledger. And so essentially, if you look at each block being transactions that are recorded to the ledger, and they're just added to the ledger, every time a new block is added to the chain. Is everybody clear? Do we have any questions yet on that, David?
Well, there are a couple of questions, but not specifically on these points. I guess those will come in a moment, but I'll get through these two questions. What are the directions to increase performance and reduce costs? That's from Sam.
Okay. Well, blockchain can be used to take some. Well, let's talk about financial transactions, right? For example, blockchains can be used with the cryptocurrency protocol to move funds quickly and efficiently, much quicker than banks do today. For example, using the SWIFT system, or using, if you're sending a wire transfer, and everybody can see that this has happened. It's been secure. So it takes a lot of that back office processing out for the banks in that specific example, and it will allow them to reduce their costs and maybe redeploy those resources.
Okay. This person's only identified as owner. Explain the bad side of blockchain, because with all the information out there, what are the liabilities?
Well, the challenge with a blockchain, first of all, is that it's got to be designed properly, as with any type of technology system, and especially if you're talking about value, such as finance or digital identity. So you have to have it designed properly so that it keeps that information secure. But one of the biggest challenges is the same with any real cybersecurity product. It's the weakest link is going to be the individual, right? And right now, one of the challenges is how do we deploy this technology and make it more user-friendly so that we can help people use it and prevent them from making those mistakes. And like I said, we're at the early stages, sort of like when everybody was using, text-based screens on the internet. The GUIs and the user interfaces aren't perfect yet, but that's what we're working on.
Benny has a question. Do you expect blockchain to replace SWIFT?
Yes, I believe so. SWIFT is old technology, and the banks are actually looking at this as a way to replace SWIFT, and I believe that will happen. That's the goal.
Okay, that's our questions for now.
Okay, so let's move on a little bit further. So let me give you conceptually, a way to think of this. If you look at these different colored little boxes. Think of those as transactions, okay? Maybe they're people sending money to each other, or maybe it's tracking movement of inventory or goods along a supply chain, but they're just transactions, data transactions. And they get strung together to create a blockchain. You put transactions together in a group, we call that a block, and then we string them together. So if you think of it, a transaction is like a line in a book, okay? You put a bunch of lines together, and then you get a block, which is like a chapter in a book. You string together a bunch of chapters, and you get the entire book. And that's what the blockchain is, really. It's the entire book. It's the entire history of these transactions and this value, so that you can go back and look at the entire history through the transactions in this chain, okay? Another easy definition is a continuously updated record of who holds what. If you're talking about value, if you're talking about a ledger, that's basically what's happening with banks, bank ledgers, and other things. So on the left, we've got an Excel spreadsheet. On the right, we've got a checkbook ledger, right? The difference between these two things, without getting too technical in the background, when you update an Excel spreadsheet, you're replacing the data in there. And so that spreadsheet's giving you the current view, but it doesn't give you the history of all the transactions that came before it, okay? When you look at your cell phone, your checkbook register, you append data into that register, but all of the previous data is still there. The history of that ledger is still there. That's what blockchain is. Blockchain is more like your checkbook register than an Excel spreadsheet, okay? So I'm going to take you through a short example of blockchain using paper with no technology involved, just to see if we can help you get your brain around this concept, okay? So let's assume we all live in a small village and we transact with each other throughout the day. We buy, we sell, we trade, whatever we do. Every time we make a transaction, we are going to let the village accountant know, and the accountant's going to add these transactions to the register every day, okay? And we all, we're all participating in this together. At the end of the day, the accountant's going to take that sheet and nail it up on the fence outside of City Hall in the town square, and over the nail he's going to put a wax thumbprint, okay? And what he's doing is he's posting this ledger so everyone can see it. It's transparent. Everyone can see it and know that these are the transactions, and everybody agrees to them, right? Because they've all been shared with the accountant. And by overlapping the nail and the wax thumbprint, what he's doing is basically showing you that all of the sheets before it are still valid because nobody's ripped them down and tampered with them, okay? And by doing that, you can actually look at all of these sheets going back to the first one. And so there is a history, much like your checkbook register, going all the way back. And the accountant has secured that transaction history by showing you he's got his thumbprint in the wax, and you can tell that nobody's taken that sheet down and altered it in any way. And that essentially is what a blockchain is doing, except instead of having thumbprints with wax, right, we're using cryptography, and we're using a network of computers to store this ledger. But essentially, conceptually, that's what we're doing. And then there are many, many accountants for many, many villages, and they're all being synced up. One way to think of this, because it's a decentralized network, is if you remember Napster, okay, was designed to be a peer-to-peer network, and was huge when people started file sharing audio files. And individuals on their computers were sharing their files with other individuals around the world in a peer-to-peer manner. But Napster's gone. So what happened? Why was Napster shut down? Well, Napster was a decentralized concept, but it actually had a centralized system. There was a company called Napster. They had, a centralized computing system, and all of the nodes on that system were tied in. And so when it was deemed to be copyright infringement, the government just had to go to Napster and pull the plug, okay? Because it was not sufficiently decentralized. Fast forward through many other iterations of things, we finally get to BitTorrent, which is the current file sharing protocol on the internet. It is still active. Why did BitTorrent survive? What is the difference? Well, BitTorrent is completely decentralized. The nodes are all individual. They connect to each other like the internet. There's no central server. All of this is being processed and done on the individual computers on the network like the internet. So they can't go anywhere and shut BitTorrent down. There's no single source of code. There's no central, it's completely a decentralized network. And that decentralization is core to implementing a blockchain ledger. Okay, let's check in with everybody conceptually. Are they with me still?
Okay, Mark has a question. If blockchain is so efficient, then why do I read about Bitcoin needing massive amounts of computing power and energy to create new Bitcoins?
So that's what's referred to as the mining process. That's how the network is secured. It gets down to how do these various nodes on the network achieve consensus of what the truth is, and be able to publish a block. Bitcoin was designed so that in order to secure the network, these miners, these Bitcoin miners, these nodes have to do some work to show that they've invested in securing the network, and that's where the use of the electricity comes in. I'm not going to get too far into the weeds on that. There are differing opinions, right? The media really focuses mainly on it takes a lot of energy, and Bitcoin network is equivalent to all of the energy being used by a small country, and that's true. The flip side to that is that energy is being expended to secure a financial system, much in the same way that if you look at the global financial system, add up all the energy being used to secure that, right? All the computers for all of the banks, all of the executives flying around on the planes, all of the offices, all of the branches, all of the people driving to work. There is also a cost in energy to secure that financial system. But because of the fact that this energy is being expended, the miners, it's in their best interest to find the cheapest energy. So a lot of green energy projects are being developed as a way to reduce energy costs. And also many of these miners are setting up shop in areas where there's access to, for example, to hydropower. And a lot of that power goes unused. So they're tapping into unused resources. So there is a lot you'll hear about that, but there are different views on that, and you can read about those. There's some really good studies and articles published regarding that.
Okay, thank you. Ian has a question. Can you talk about the entry points for people with different expertise? For example, IT professionals, business professionals, etc.
Yeah, so the first entry point is what you're doing here, right? It's getting a baseline understanding conceptually of what this is. And then being able to take your expertise and see where it can apply to these things. So if you are an IT person, right, there are many, many different areas within IT that you can get involved in with blockchain. One would be if you're a developer, right, being able to write code to do blockchain solutions. One would be a network or a systems engineer, being able to design, because you've got these decentralized networks, so you need to understand the communication protocol, the consensus mechanisms, keeping everything in sync. Cybersecurity, clearly, making sure that you are providing protection to the network. If you're into mathematics and cryptography, there's a whole area to get involved as well. So once you've understood, once you get through this and you understand conceptually what it is, then you can go off and do your more specific research into things. But it's not just technology. Like I said, you can be in sales or customer service or accounting, And these blockchain companies and these startups, they all need the normal, regular, everyday HR, everything that goes with running a business.
Great, thank you. Bruce has a question. The early internet had a lot of support from the US government. Is there any similar common infrastructure ownership of blockchain at this point?
No, there is not. At this point, all of the infrastructure, for the most part, is being privately put in by corporations and individuals. But in some areas, there are some places where the government is more involved. So countries like Estonia are starting to invest in that from a governmental perspective. Dubai is looking to build a smart city, which is built on blockchain technology. So I'm sure you'll see more investment from the government there. The US really does not have a strategy in place yet around blockchain. Legislatively, there's still a lot of education going on, but we may see that. We may see some public-private partnerships come about in the future once the government figures out how they can leverage this.
Okay, Nick has a question. How secure is secure? Are there any efforts to ensure the chain will never be broken by a hacker or a group?
The only evidence we have so far is that the Bitcoin blockchain, which is the first one that has launched almost 12 years ago, has been running for 12 years and has never been hacked or breached. You hear about hacks with Bitcoin, but those are not breaches of the blockchain. Those are breaches of the on-ramps or the off-ramps, okay? And that's where the human piece comes in. These are systems that are connected to the blockchain, such as financial exchanges or digital wallets. That's what gets hacked. It's not the actual blockchain itself. So far, the expenditure of all of that energy to secure the blockchain has proven to be the solution that works. Now, there are a lot of projects and a lot of work being done to figure out how can we achieve the same bulletproof type system without expending all of that energy. So, again, a lot of research is being done into alternatives that are much less reliant on using up electricity.
Thank you. Dara has a question. Why did it take so long for blockchain technology to be a thing, considering your accountant and the town square transactions posting example?
Great question. That gets back to that double spend question. It gets back to the issue of digital uniqueness, okay? Prior to Bitcoin being launched, for years before, there were several projects. People were trying to develop a way to have digital currency, digital money, e-money, whatever you want to call it, without being centralized. You could do something if it was centralized, right? If somebody was controlling that. The problem is if it's centralized, somebody's in control of that money and can change this system, can alter the system, can be hacked, okay? And so the holy grail was, how do we develop a system that's sufficiently decentralized so we can keep it secure, but we can't allow people to double spend because of that analogy I gave you of if you have a JPEG or you have a file, once you send it to somebody else, you're sending them a copy and you still have a copy. With this technology, you can send somebody that value. You can send somebody a digital dollar or a digital Bitcoin. Once you send it, you no longer own it. That now belongs to the other person. And that was the big breakthrough in what Bitcoin did that allows this technology now to go forward.
Thank you. Ian has a question. Regarding entry point, can you recommend user groups, trainings, etc.?
There are many. In this area, mostly there are groups and training areas in New York City. New Jersey does not have a lot of them yet, but there are some good online resources, like Blockchain Academy. Like I said, there's several of them. You can start, if you want, by finding some of these things on some of the free resources, like I'm drawing a blank. David, what are the university ones, right, where they put up courseware.
Like Coursera or MIT.
Drawing a blank.
Yeah.
Coursera, yeah, yep. Coursera has a course or two, but then Udemy, UDEMY, is a site where people put up courses, online courses. There's a lot of good courseware up there. You can get some for as cheap as $10 when they put them on sale. There's some YouTube videos, so there are a lot of resources where you can start to learn about this. So that's what I did. I just started looking around, and I started finding places and taking as many courses as I can. I believe there may be some on LinkedIn as well in their educational area.
Okay, thank you. I will put a link in chat that has a link to 38 e-learning sites, and that's the questions that we have now.
Okay, good. All right, so I'm going to take the training wheels off a little bit. We're going to talk a little bit about technology, right? So I want you, this is where you'll hopefully get the light bulb moment. And I'll go through this slowly, but David, if we have any questions, like at the end of each slide, that may be more appropriate in this section, okay?
Very good.
All right. I'm going to show this video because I think this helps. You won't be able to hear it, but this video fortunately has the text across the bottom, so you can follow along with what's being said. But I think this may help as a starting point.
When you want to buy something normal bank, give the card shop, the shop asks the bank. If I do, no, it updates the records. It shows the shop. Now, if you the idea is don't have sensitive records ledger around the world. Each owner of each property is every. So to buy something using cryptocurrency, give the shop. The shop asks all the bookkeepers if I give them the money. The bookkeepers all check their records, see if I have enough. If I do, they tell the shop, all update their records. So there's no way that a forged transaction if I try to alter a ledger, it won't match all of the other properties. Oh, and one of them, at random, will be given a reward. And remember, all of these bookkeepers, all of these ledgers, they're not active.
All right, I want to stop there real quick and just, does that help you start to get your brain around this concept of how using a distributed ledger where everyone is keeping track and prevents people from cheating? Does that help? Anyone really lost?
Well, there are no questions or comments yet, I guess, because the video just finished.
Okay.
One person, but one person wrote yes. Another person wrote yes. That example did help me.
Okay, good.
So I think in general, yes, so far.
Yeah. And remember, I talked about Internet of Value. So you can think of that same example where the value is no longer a Bitcoin or a cryptocurrency. The value is now something else, a stock certificate, ownership of your home, your digital identity, could be any of those things. So to understand the strengths of blockchain requires you understand a little bit of the technical architecture, all right? And what I'm talking about here are something called a hash, a Merkle tree, and then consensus. And I'm going to walk through these, and hopefully this builds on your knowledge till you get that light bulb moment. So what is a hash? Well, in computing terms, simply it's a digital fingerprint for data, right? It allows you to uniquely identify data. Hash is both a noun and a verb. So we will also refer to a hash as the algorithm that actually creates this digital fingerprint, right? It takes some input and it creates output. So you run a hash algorithm and you get the actual hash of that data. The key here is that the same input will always give you the same output. As long as the data that's going in is the exact same and hasn't been changed in any way, you will get a hash, hence the term digital fingerprint, because if you change the input, that's no longer unique data, but it will have a unique hash. And hashing is basically a method where you can calculate a fixed size output really for any size input. So you could put one word in a hash algorithm and you will get a string, right? And if you're using a hash algorithm like SHA-256, for example, it's going to be a 64 character hexadecimal string. So it's a fixed length. One word will give you a hash in that format, but you could put the complete works of William Shakespeare into that algorithm. It will give you a hash, a fingerprint, a unique identifier for that input, and it's the same length. It's also a 64 character string, okay? Anybody lost on hashing yet? I'm going to keep going through this but hopefully I haven't lost you yet.
Questions of such didn't pop up.
Good. So this is visually what I'm talking about. You take some kind of input.
Well, hold on, one hash question.
Okay.
Is each hash unique?
Each hash being the string of characters. Yeah, it is. Mathematicians have calculated, because this is random, they calculated what they call the collision probability of getting the same random hash for different inputs. And it is such a random number, it is so large that basically mathematicians have said it's all, for all intents and purposes, they consider it to be zero. I'm not smart enough with math to be able to do that calculation, but I trust them. So basically, you've got an input, you put it through your hash algorithm. Like I said, one example is SHA-256. There are many, many different types of hash algorithms that do different things. Their output will look differently than this because each one has its own format, but this would be the hash value in SHA-256. So that would be your digital ID for whatever data you put in. It's your digital fingerprint for that data. So what does that look like? So here's an example. Do you guys see my cursor moving at all?
Yes, we do.
Okay, I'll use that as a pointer. If you look here, you see this text, hello world, with a capital H and a capital W. If you hashed it in SHA-256, here is your hexadecimal string. That is your hash. That is your unique digital fingerprint, your ID for that specific text. If you add this exclamation point to the end and run it again, you will get a completely different and random unique digital ID because you have changed it. If you now take these capitals and make them small lowercase letters, you will get another unique digital ID, a new hash string. And these are all, even though these are similar inputs, these are all completely random and unrelated to each other. Is that clear? Everybody still with me?
Yep, so there's one question on that, and then I'm going to go back to one or two other questions. Is it possible to work the hash backwards and therefore come up with a class of inputs to generate the same hash? Is this a flaw in the algorithm?
No. A hash is a one-way function. So it's a little bit different than encryption and decryption, right? If you're familiar with encrypting files, you use your encryption key to create a jumbled file, right? An encrypted text, but then you can use that key to reverse it and get back to the original. This is a different type of cryptography, and it only works one way. So once you've made the omelet, you can't unscramble the eggs, so to speak. So if I show you this string of characters, right, you cannot determine that this was the input that created it. But if you want to verify this input, you can always run it through the hash algorithm again, and you will get the same string. So you could verify the validity of the input. Okay?
Very good. Judith has a question. This goes back, I think, to the video. The bank takes a cut. Does the blockchain take a cut?
Good question. It depends upon how you've structured the blockchain, right? Because you can design your system anyway. The system with Bitcoin, for example, is that when a node creates a block and adds it to the blockchain, they get paid a reward, but that reward is released from the code. It's newly issued currency. Additionally, as the as the sender of the transaction, you can put a fee on there to reward the node. You can put 0 fee, or you can put a higher fee. Many times, if you have a very time-sensitive transaction and you want to make sure it gets added to the next block, you'll put a fee on there to incent the miner or the node to put it in the block, but you don't have to. Some blockchains are designed to be not have any fees and have a different incentive structure. But that's a good question. It really gets down to how you designed your blockchain and what the purpose is.
Okay, that's where we're at right now. Good.
Okay, great. So here's another example, same thing. This is a test, and if you took off the capital, different string. And remember, I said your input could be anything. It could be a PDF file. It could be a Word document. It could be a video, right? Because the algorithm will actually take the core, binary code of the file and create a unique digital fingerprint. Some of you, if you download software, for example, you may have come across this thing called a checksum. And if a software developer wants you to be able to be comfortable that you have downloaded the original file that they have posted and nobody has altered it in any way, they will publish the checksum, which is nothing more than a hash of that executable file. When you download the executable file, you can run it through a hash algorithm, and because it's the same exact input, you will get the same checksum. That's how it's used in verifying software, for example. Any questions on that? Nope. Okay.
Nope, no questions.
Okay, so now we understand the concept of a hash. How do we use that within the concept of a Merkle tree? So bear with me. Think of L1, this block down here, as a transaction. And think of L2 and L3 and L4, as transactions, okay? You can take that transaction, run it through a hash algorithm, and you will get the hash of that. So you will get a unique data string representing this data. You could do the same thing for L2. You will get a unique data string representing this data, and so on and so on. Because the hash is a data string, you can rehash that string. So you could take the hash of L1 and the hash of L2 and put them together, and now you will get a hash of these two data strings, right? So now you've hashed them together. So essentially, the input L1 and L2 are all baked into the hash that got hashed together up here. And if you continue to do that all the way up to the top of this tree, that's called the Merkle root because it's named after a gentleman named Merkle who figured this out. You get a hash of all of this data that's been hashed together various times. And remember, this is a unique digital fingerprint, and it includes in it all of the data that started down at this level. If you were to change any data in this input, it will change this hash. If you change this hash and combine it with this hash, you now have changed this hash. If you've changed this hash and you've combined it with this hash, you now have changed this hash. So you can very quickly tell if any of the inputs anywhere in this tree have been changed, because you will now change the hash at the top. Does everyone understand that concept? Is everyone still with me?
No questions came through.
Okay, good. Why is that important? Because as blocks are added to the ledger, are added to the chain, we take all of those transactions to get the Merkle root, like we just learned of, but then we have a header within each block. Each block has a header which says it's the date and time stamp, who created the block, what the block number is, and it takes the hash of the previous block and puts it in the header of the next block. And by doing that, you've now taken and baked into this block, block 2, all of the transactions from block 1. So if any transaction in block 1 changes, that Merkle root changes, so the hash of this whole block changes. If that changes, you have to change it in the next block and refigure that block, because otherwise you'll get a different hash, right? So if you do that throughout the block, the first block is always called the Genesis block, right? It doesn't have a previous block hash, so it just has zeros in there. But you create the hash of this block, and then you add it to the next block. And then you create the hash of this block, which includes the hash of the first block, and you add it to this block, and so on and so on and so on. So if any data were changed in any of these blocks, every block that comes after it is now invalidated, and the whole network knows it. Does everybody understand that concept? Does that make sense now that you understand what a hash is and how it gets used to chain the blocks together?
Well, no questions came through. Of course, it could be people now are just starting to digest it. So I guess what's possible is we may get a question in a moment about a prior slide.
Later on.
We'll just, yeah.
Okay. The third concept you need to understand in distributed.
One came through.
Great.
That's okay. Why is it called Merkle root versus Merkle treetop? That's from Dara.
I don't know. That's just the name. It's the root. It's the root hash, and that's just the term that was given to it by Merkle, I guess.
Okay.
All right. The next concept is consensus. In the world of distributed computing, right, there has to be a way for all of these nodes on the network to agree what is the current state of the ledger, right? And that's called consensus, which means what you probably think it means, right? It's an agreement between the parties, between the nodes. The concept here is that the more independent witnesses who all testify to the same fact, the higher chance that this fact is true. So if there are 1,000 nodes and 999 of them all agree and one is different, the probability that all of the 999 are correct makes sense, and that they can reject the other node that doesn't. Consensus is where the economic game theory comes in, and the blockchain has to be designed with a consensus protocol to make sure that this blockchain has a properly functioning consensus mechanism that allows for, fairness in how it's done. The consensus mechanism used in Bitcoin is called proof of work. That's where the energy usage comes in. They are doing a lot of calculations to basically solve a mathematical puzzle. And once they've proven they've done the work, they can publish a block and all the other nodes can verify it and get consensus. There are other types of consensus. There are staking consensus, proof of stake. There are others. So I don't want to get too far into this, but just understand the concept that there has to be a consensus mechanism within a blockchain. And the consensus algorithm is basically, it's the algorithm that elects the next node to add the block. So all of these various nodes are collecting transactions. Once one of them is chosen, they're going to put the selected transactions into the next batch, the next block, and append it to the blockchain. You can think of it as a lottery in a sense, right? It's a lottery that all of these nodes are in the lottery, and if their ticket gets chosen, they get to enter the next block, and they get a reward for that, and everyone else on the blockchain can verify it using these hashes and verify that they've all got the same data. Okay? That's consensus. So those three pieces of technology, if you understand them, you can start to understand how these things work. There's a video that I'm going to skip. So,
excuse me, Lindsley.
if you, yes.
Yeah, so one question from Bruce. Did you say the Merkle hash is copied into each block?
Yes, if you take everything within a block, right? You build the block, you add the header, everything there, you're going to hash the entire block. Everything in that block, it will get a hash, right? In that is also the Merkle root of the specific transaction. So the Merkle root and all the header information then gives you a block hash. And the Merkle root is embedded in that block hash. That block hash is then embedded in the header of the next block, which means it's embedded in the next block, the whole hash.
And Valerie has a related question. If the hash is copied into the next node, then does each node grow exponentially?
I think what you mean by that is the actual data structure, the blockchain itself. And yes, they do grow. The Bitcoin blockchain, which has been running for about 11 or 12 years, is somewhere about maybe 275 gigabytes in terms of the size of the data. It's a lot, but considering how long it's been running, it's not terrible. And considering we have terabyte-sized laptops now, but that is another area in the development and design of the blockchain, is how much data are you going to store, and how are you going to store it so that you can have maximum efficiency. Any other questions?
Yeah, Rajiv has a question. Is there a risk of the tree getting corrupt and we lose entire integrity?
Technically, there is a risk. It is very, very small, and I'll explain that here. Let me show you. If you think about these blocks, right, being added to each other and building the chain, the network is always working on the next block to put in. And remember, the next block is going to be linked to the previous, basically it's linked to every previous block back to the first block. If someone tries to corrupt a block, every block after that is invalidated. So if they want to take over the network, they have to rebuild every block after it and put the next block on in order to take over the block and corrupt what we consider the truth. The reality of it is that you have to have at least 51% of the computing power on the network to achieve that. And even if you do, you're not guaranteed to be able to get the next block because it is a random process. But on the Bitcoin blockchain, for example, the amount of computing power to rebuild all of the blocks after this block and get the next block within the time allotted, it's financially prohibited. You just can't do it. So for all intents and purposes, we say it's immutable. And the further that block is baked into the blockchain, it's that much harder because you have more. Now, could you attack this block here? Sure you could, but you still have to win the lottery with this block and convince everybody to change. And that is very, very difficult. It essentially never happens if you've designed the blockchain properly. But again, these are all design and engineering issues around distributed ledger. Any other questions?
Yes, Giacomo has a question. Are any quantum computers working on blockchain technology yet?
Not yet. I mean, quantum computing is still somewhat in its early phase. There is a concern that at some point the cryptography used to secure the network could be cracked by quantum computers. So there is also development going on to build the next generation of cryptography and hashing, which would be quantum resistant. So at this point, there really is not, there's not a big concern that these things could be broken. And, you know, the other thing is that if a nation state like the US or Russia or China developed a quantum computer that could break this, I guarantee you they're not going to try to go after a blockchain or go after Bitcoin. They're going to not let anybody know they have that, because the most important thing that they want to go after are, for example, Russia's and China's keys to launch their nuclear codes, right? And they don't want anybody to know that they've got that capability. But just so you know, it is a cat and mouse game. There will be people developing the next evolution of this stuff to be quantum resistant.
Okay, thank you. Let's keep moving.
Okay. So when we talked about proof of work for securing Bitcoin, right, it started out that you could just run it on your computer and then on your CPU. Then they started using GPUs to run these calculations. Then people figured out if I could set these up in, you know, in my living room or my garage, I can, you know, run more of these and try to win this lottery. And it got to the point where now there's data warehouses full of these mining devices, to the point where now the Bitcoin network actually calculates 111 quintillion hashes per second. That's a huge number. By design, it takes about 10 minutes to find a block. So if you think about all of that hashing power, that's securing the network. If Google dedicated all of its machines globally to mining Bitcoin and doing nothing else, it would make up less than 1% of the total network power of Bitcoin. Bitcoin, for now you know, is the single largest distributed computing network in the world and the most powerful and the most secure in terms of processing power. That's where the security of Bitcoin comes from. And that's where development of these other consensus mechanisms other than proof of work, which require this investment, is part of the development of the future of blockchain. But this is how Bitcoin has been secured all these years. All right, everyone okay with that from the technology side?
So we have a question from Barbara. It sounds like this product may be useful in medicine and genetic research. Could this be used outside of finance?
Absolutely. There is the ability to take a lot of this disparate data, for example. So let's say I have my personal medical data and my genome sequencing and everything with my related diseases, and I'm storing that on a blockchain, and I am the only one who has the key to unlock that, right? We could take all of this data, make it available to a research organization who wants to run, algorithms across, or AI across this data. The data could be anonymized. Nobody knows it's mine. I'm just making the data available, not my identity. And I could be paid for that, because in order to use my data, this research firm could offer me $50 or $100 or something, right? And then all of this data could be run on these algorithms, and we could find ways to, maybe find cures for certain things, or find ways to better predict certain diseases. So yes, there is a lot of development going on in the healthcare area for this as well.
Okay, thanks. Let's keep moving.
Okay, great. I want to just give you a quick overview of another concept you'll hear about. This is another area where there's a lot of power in blockchain, and it's called a smart contract. And a lot of people think that, blockchain and smart contracts are at the same point as where we were with the web in '94, and that over the next 20, 30, 50 years, we will still be developing this power, much like we're still developing and unleashing power of the internet with new technologies, right? It started with things like email. Eventually we had websites, then we added e-commerce and shopping, and we're still building on those things. The concept of a smart contract comes from taking Bitcoin and coming up with like the next generation. And so Bitcoin was a way to exchange value across these computers. This young man here at 17 really came up with this idea of taking it a step further, and instead of just exchanging value, basically creating a world supercomputer, which is a platform where you use a virtual machine within each computer to run a decentralized application. And the concept being, if Bitcoin was a calculator, Ethereum would now be a smartphone. Takes it to the next level, and basically uses blockchain instead of storing, let's say, a Bitcoin as value, it stores a software program as the value. And that software program is now on all of these computers on the network, and all of them can run that app. It's called a decentralized application. And by running it on a network like this, everybody can verify that they all got the same result before they use the output to publish to the blockchain. So if you think about a contract, right, as a legally binding agreement between two or more parties, a smart contract basically just is a piece of software that takes the terms of that agreement and executes it on the blockchain without needing human intervention. One way of thinking about that, and I can't run the video, but is think about a vending machine, right? You put your dollar in, you hit the button, and you get your bottle of soda. Essentially, that's like a smart contract, right? There's no human intervention. There's no person sitting inside the machine physically giving you your soda. It's all programmed in, and you give it the right input it's looking for, it's going to give you an output. So, you know, on real simple terms. But you could also think of it this way. Think about if you lease an apartment in an apartment complex, and you've got an agreement, right? On the first of the month, I pay $1,000, and that gives me the right to use the apartment again for the month. And let's say you're using a smart lock, an IoT device that's connected to the internet. Now you've taken that lease contract and built it into a decentralized application on a blockchain. When you send your money to the bank, right, it triggers that application to run. Everybody verifies it, everybody knows, the ledger gets updated, and your lock and digital key for that apartment is now updated and you can get in. If you don't, then you don't get access because the digital lock stays locked. That's a very simplistic example, but hopefully conceptually you can understand. Clearly there are legal, social, ethical, other repercussions that have to be dealt with, but just to understand the concept of how a smart contract could run on a blockchain, it would take out the middleman. You know, nobody has to come collect the rent. You don't have to take it to the office. It's not dependent on if you pay your rent, they forget to change the lock. It's all automated. Any questions about that? Everybody understand that concept?
No questions at the moment.
Okay, so we'll skip over the video. Okay, so let's talk about a few use cases now that you conceptually understand. These things are being developed by the world's largest corporations, by entities such as United Nations, by countries, right? By government agencies, many use cases. We've talked about financial services and payment systems. Let's just take a look at what that means. I tell people you don't understand Bitcoin because you think money is real. The truth of the matter is that almost all of our US dollars, 90 to 95%, do not literally exist in any tangible form, right? Over 90% of US dollars around the world don't exist in bills or coins. They are simply digital entries on a ledger, on a bank ledger somewhere. So the analogy is you've got so much money in your bank account, but you only have so much cash in your pocket. So most of what you're dealing with is already a digital currency. It's just that Bitcoin takes that to 100% as opposed to 90%. And why is Bitcoin so popular in financial services? Well, cash is a currency, but it's not a payment network. PayPal, Visa, Venmo, they are payment networks, but they are not currencies. Bitcoin and cryptocurrencies are both a currency and a payment network simultaneously. It's self-contained. So you don't need a payment network middleman sitting in between that. So here's an example. Let's say you want to send money to your relatives overseas. Let's say somebody went to work in Japan and they have family in the Philippines. Currently, you have to go through a remittance process where you go to your bank, you give them that amount, you give them a fee for that transaction. That bank takes the fee, they transfer the money to an intermediary bank, which takes a fee, and then converts that currency into, the local currency. They send that to the receiving bank in the receiving country. They take a fee, and then it gets delivered to the person at the other end. And so you've got 3 banks in the middle in this example, all taking a fee, costing money. And this process, using a wire transfer, sometimes can take as long as a week to some parts of the world. So it's slow and it's expensive because of those intermediaries. And the reason those intermediaries are there is up until now, you needed somebody in the middle to be able to trust. Now, with a system like Bitcoin, it's all baked into the system. You send your money through the network, it's open, it's peer-to-peer, it's secure, it's instant, and it's essentially free, and it goes directly to the other people on the other side. It is a currency and a payment network together without a third-party intermediary. Such as, you can take, and this was done back in October of 2018, someone moved $194 million worth of Bitcoin from one address on the network to another. It was instantaneous, and the network fee to move $194 million was 10 cents. Think of the implications of that for international finance. Think of the implications for that of, businesses moving money using the banking system, using wires, using SWIFT. You'd probably pay hundreds of thousands of dollars to the banking system to move that money. So this is a major breakthrough in financial services, both for individuals and for the system. The Australian Securities Exchange is working on replacing its clearing system for stock trades with blockchain technology. So now think about that piece of information, that value represented on the blockchain is the representation of the ownership of a share of stock. Typically, when you trade, you have to allow up to a week for that trade to finally be processed because someone's got to go back and verify that you actually own that stock, that stock can be delivered to the other party. And that's what clearinghouses do. There are physical pieces of stock that still sit in locations in Delaware and other places. If you represent that stock as a digital entry on a blockchain, that can happen quickly and efficiently and immediately. We talked about a little bit about supply chain. I'm not going to show you the video, but if you think about, so the Port of Antwerp in Belgium is working on streamlining their operations, and they say moving containers from point to point often involves more than 30 different parties, resulting in hundreds of transactions. So let alone the fact that a lot of this is still on paper, all of these different parties are using all of their own different systems. They're not connected to each other. They're not sharing information. You can use a blockchain-based system, put that information on a blockchain, and people can then look at where this stuff is, what is the current state of that, where was it from, did it clear customs, who was responsible. You can put other assets to track online, such as land registry, who owns a piece of property, right? Because the ownership of property requires, lots of different documents and investigation. It's time consuming. Sweden and the UK are looking at doing that. Think about, for example, when Haiti was hit by that terrible hurricane. It really destroyed the country, right? Think about someplace like Cuba when Castro took over and the government confiscated private property, right? If you want to have a definitive source of the truth of who owned what property when it was transferred and who was the rightful owner, you could put that on a blockchain. And let's say Cuba was freed and liberated. How could you get that property back to the rightful owners before it was confiscated? If it was stored on a blockchain, you could. With a lot of the current systems trusting the intermediary, It's very easy for somebody to go to the land office, bribe somebody, change that documentation, and effectively steal your property, right? They can't do that with a blockchain solution. Digital identity, right? We mentioned that. You can put digital passports on the blockchain. You can put your personal data, your education, your certifications, your work history. You can put your healthcare data. You can prove who you are, and you can prove and release information without having to release unnecessary information. You can prove yourself. The example would be if you went to a bar to prove you're old enough to drink, you show them your license, but they also now are looking at your address, your height, your weight, the color of your eyes. All they really need to know is that you can prove that you are old enough to drink. You can put that information on a blockchain and just simply show them proof of eligibility and not have to share the rest of your information. Gaming is another area. There is a lot of development going on with gaming using blockchain that allows you to take the assets that you acquire within a gaming environment, put them on a blockchain, and move them to other blockchain-based games. Right now, if you go to World of Warcraft or Fortnite and you spend money developing a character and achieving things, getting clothing and weapons, that's all contained within the centralized system of the game. If that game shuts off, you've lost those assets and the money that you've invested in them. If it's a blockchain based, you can own them and move them, sell them, transfer them to another game. Voting, we talked about that. You know, so there is a company, for example, this is one of the projects being developed called Votes. There are a few others that are being developed. I did have a video, but I can't show that. But in Zug, Switzerland, they've already piloted that project and they're working together with the government to test this. And many, many, many more use cases, to the extent that if you look at, you know, any industry, mobile payments, border control, supply chains, energy, the diamond industry using supply chain. How do you verify that a diamond was mined ethically? It's not a blood diamond and it wasn't supporting, you know, torture and war in Sierra Leone. All of these things, real estate, advertising, you know. And then within these different areas, there are a host of companies that you know, people like IBM and 3M and you know, large banks, but also a lot of startups that you haven't heard of before. And a lot of these startups are very well funded because you know, billions of dollars has been invested in the blockchain industry over the last several years. So any questions on that stuff?
Yeah, so a couple questions came in. This is from Bob. Is there a need to define a standard for transactions? In other words, Bitcoin versus a competitor?
There is for certain use cases. That development is what they refer to in the space as interoperability. So you can run a blockchain like Bitcoin, you can run a blockchain like Ethereum, you can run a blockchain like Blockstack. They all have their different protocols, they all run differently. There are people developing blockchain services for interoperability that would allow you to move value between blockchains and interact and communicate with other blockchains. You know, like I said, this is all very much in the early stages, so that mountain has not been climbed yet completely, but those projects are ongoing.
Next question is from E. That's just how this person's identified. With Bitcoin, will real cash bills and coin currency be printed in the future?
That's a very good question, and there is a serious discussion going on about what is the future in a cashless society. A cashless society, as implemented by the government, would be essentially a digital currency issued by the government entity. And then the government entity would take the remaining physical cash out of circulation. Unfortunately, what that does is it takes state-level surveillance and applies it to financial transactions. And it means every time, which you have today, right? Every time you use your Visa card or you use your banking system, all of those transactions are tracked. if you want to remain anonymous, you can buy something with cash and they can't track you. If we went to a system where a state entity went to 100% cashless, the value of something like a cryptocurrency is that you can have cryptocurrencies designed to protect your identity because you're not using the financial banking system or the government-owned system in the middle of your transaction. So Bitcoin itself is not, technically it's not anonymous. You can obfuscate things, but there are other currencies that are designed to be anonymous, such as Monero, such as Dash, such as Zcash. And those are developed explicitly for the purpose of preventing state-level surveillance of your financial transaction, because the thought there is that freedom of how you spend your money ties exactly into freedom of speech and freedom of liberty, because if you can be punished after the fact because you donated to a political party or you supported a cause or you financially supported something that someone else deems unacceptable, they can punish you after the fact by kicking you out of the banking system, by closing your bank accounts and not giving you access to the financial system. And that's a de facto way to actually shut down your freedom of expression.
Okay, A has a question. How has your knowledge of blockchain impacted your career?
Well, I have done a pivot. I found early on that there was a real need for education. So I've been focusing on trying to help educate people in this space, much like what I'm doing here with you guys. But also, I just finished teaching a summer session as a paid engagement. I just taught a summer session for Columbia University, and am looking at other opportunities where I can go forward in the future and earn and make a living teaching this to students and people through universities, through other types of learning environments, and also continuing to do the free work that I do, through groups like this to help educate people as well. And consulting, being able to consult with businesses with my business background and my blockchain knowledge.
Ricardo has a question. I didn't see Amazon. Are they using this?
Amazon will be implementing this. Clearly, the supply chain aspect is something that is of value to them. Also, the financial side. If Amazon came out with essentially their own cryptocurrency, right, Amazon coin, and they could take Visa and MasterCard out of the middle, and they could allow people to use their network using their own cryptocurrency coin, they could save that 3 to 5% that they're paying on all the transactions. So again, there's a lot of cost savings. So yes, people like Amazon, Microsoft, all of the large corporations are looking at implementing blockchain in one form or fashion.
Okay, let's move on.
Any other questions? Is that it? Okay.
Yeah, that's it.
So what's the future? Well, I like to say that technological evolution drives further innovation, much as we've seen with the internet, right? As some new technology got added on top of the internet stack, it drove further innovation and new things were going. I think we're going to see that. So like we couldn't have had Netflix in 1992. We didn't have the bandwidth. We didn't have the compression algorithms. We couldn't effectively stream video. But as more people came on board to the internet, as we built out the infrastructure, as we built out bandwidth and got more high-speed bandwidth, as compression algorithms were developed, we could create Netflix so that you could stream a movie online, which you couldn't do in 92. And part of that's driven by the fact that in 1994, you had less than 3,000 websites, but by 2018, you had 1.8 billion. So there's scale there, and it allows further technological evolution. Many people think that cryptocurrency will be the equivalent for the blockchain like email was to the internet. Email was the big killer app that got most people connected to the internet in the early days, right? If you think about the universal application, it was the ability to send messages. And as businesses began to use email, people then got personal emails, and then companies like AOL put a nice GUI user interface on it, and people started using AOL to use email, and then they used chat functions, then they used bulletin boards, then they used other things on the web. Money is a universal for people around the world. So if people start using cryptocurrency and get adopted and used to the blockchain space, that brings more people, more users into the ecosystem that allows further development and evolution. And I like to say, what will be blockchain's, September 4th, 1998? What will be that big watershed moment? Well, what happened on that date? We got Google, right? As the internet developed, initially there was no DNS. You had to know the location of where you were going. You could find information if you knew where to look, but when you went from 3,000 websites to millions of websites, now you didn't know where to look. So there was no need for something like a Google index in the early days, but then that developed. And then from Google, we now have a way to search the internet, and Google has evolved and morphed to the point where pre-Google, the largest corporations in the world were analog companies. Post-Google now, a lot of the largest companies in the world didn't exist in the early 90s and are now some of the largest companies in the world. Google, Facebook, Amazon, right? What will be that moment in blockchain? We think it may be related to something cryptocurrency based, but it could be something else. And maybe in 20 or 30 years time, some of the largest companies in the world don't exist yet, but will be blockchain based and will become the next Googles. So what does that mean? Blockchain is an emergent technology. It's important. Investment in blockchain continues to grow. Blockchain is being deployed in most industries in some form or fashion. It's creating new businesses and jobs. Will help many companies reduce expenses. Will disintermediate industries and take that middleman out. So you should be evaluating the impact of blockchain on you, your business, and your industry. And get in front of it. Don't be dragged along. Consider the impact, consider jobs in blockchain or cryptocurrency space, and go get additional training and education, right? Now that you have a basic understanding of what this is, you can build on this knowledge, teach yourself more, learn, and dive specifically into what's happening. The benefit there is if you're going for a sales or an accounting or a customer service job in a blockchain or cryptocurrency based company, or a prior company that's implementing blockchain projects, your ability to speak to this technology in an interview and sound credible could be the differentiating factor that gets you hired over the other candidate. Because if everybody's got all the good technical skills, right, and you and the other person may all be a cultural fit, which we know Alex and many others talk about, right? If you're the right fit and you've got the right skills, right, what else can you do to differentiate? This could be it. This could be the piece. So I encourage you to research those things. And that's it. Here's my contact information. Feel free to reach out. If you'd like to connect on LinkedIn, please, drop me a note saying, hey, I was in your presentation. I'd like to connect. I'm happy to accept. Reach out if you have any follow-on questions. I'm always happy to answer. And if you do decide that you want to pursue a job in this space, I have built connections in the space. And if I can help you network through LinkedIn to someone who can maybe help you, happy to do that as well. Are there any final questions, David?
Yeah, Lindsley. So Scott asks, with cryptocurrency that is not state controlled, is there an increased risk of fraud?
There could be, right? If the cryptocurrency is designed by people that are fraudulent, right, it could be designed as a way to just cheat people out of their money. And some of that happened in 2017 when we saw a lot of these ICOs, initial coin offerings. The good thing about this space is that pretty much it's all built on open source technology. With the exception of enterprise solutions that are being developed by people like Microsoft and IBM, most of this is open source. So you can go look at the Bitcoin code, and developers can look at, if somebody is launching a new cryptocurrency, developers can look at that code, they can hack that code, they can look for things that don't look right. And you can get a consensus from people in the space. Is this a valid project? Does it serve a valid need? But you always have to do your due diligence. You always have to try to make sure that you're not getting taken for a scam.
Okay. Deborah has a question. Can consensus be compromised by a catastrophic event, either engineered or natural, that removes a majority of true nodes and leaves a remainder of false nodes?
Theoretically, yes. You'd have to know where all the nodes are and have the ability to knock them off, and then have the ability to put new nodes on the system. That gets exponentially harder the more nodes there are on the network. With Bitcoin, for example, there are tens of thousands of nodes spread out across the world. That would be pretty hard to orchestrate, let alone for any single individual or corporation. I would argue that even state level attackers like North Korea couldn't pull that off. It'd be very hard. Now, that means that when you launch a new blockchain node and a new blockchain system, part of what you contemplate is, how do we secure it in the early days to prevent it from being compromised with a 51% attack before the network has gained scale and security. And again, that's part of the design and how you launch the network.
Okay, Dara has a question. Are big banks driving the advancement of Bitcoin/blockchain, or are they creating roadblocks to protect their interest and the money they make from transactions?
I would say the answer to that is both. I'm going to separate Bitcoin and blockchain in this example, okay? There is a movement with a lot of people where they will say blockchain, not Bitcoin. Jamie Dimon, for example, has been very vocal about he does not believe in Bitcoin as an alternative currency or store of value. He will do everything he can to talk down about Bitcoin. He will adopt the blockchain technology. JP Morgan is developing JP Morgan Coin, which will not be a retail cryptocurrency. It will simply be a cryptocurrency within the infrastructure of JP Morgan and their partners to do these back office transactions, to leverage this technology to move assets quickly and securely without actually adopting and using Bitcoin. So in many ways, they're doing both, right? They are trying to hamper Bitcoin, because if you are at JP Morgan and you are an investment banker or whatever, you are prohibited, as with many banks, you are prohibited from using Bitcoin. You can lose your job if you are caught investing in Bitcoin or using Bitcoin, but they are using the blockchain technology to benefit them as an organization. So you see them doing both of those things.
Okay, and this is a related question from E. Do you think banks will interfere or try to stop, as they will lose their commissions, sales, and credit cards, etc.?
Yeah, they have a vested interest. So I think what they've seen is that with a technology like Bitcoin, that they can't stop it. They have to develop their own solutions. So their challenge, as with any business with a new technology, is how do we pivot? How do we embrace the technology? How do we stay in the middle and add value, right? And still remain in the middle of that transaction versus, another business may look at it and say, we're going to be disintermediated and there's really nothing we can do. How do we pivot our business structure? So the banking system is looking at ways to make themselves stay relevant. But, there will be businesses in the future that do not digitally transform themselves efficiently and effectively. And I think John Chambers from Cisco has said that, in 10 years, 30 to 40% of businesses could be gone because they have not effectively figured out how to transform themselves with these new digital technologies.
Okay, well, that seems to be the last of the questions. So Lindsley, thank you so much. You know, I think the goal was, and you met it, which was give us the introduction to blockchain, have us understand, you know, some of the lingo, some of the concepts behind it. We're clearly not experts just by virtue of your presentation, but now we can begin to talk the talk a bit more, especially in our interviews where it may begin to come up. So I think you really hit the mark, and so thank you very much.
Thank you. And like I said, I encourage you all, you know, take the next step of you know, finding some of these online courses, reading about some of the projects in your chosen industry, and get a sense of how you might be able to impact your career or add these skills to your skill set. And there are jobs out there. Go Google blockchain jobs or go to LinkedIn and use the search function. And I'm sure you'll be surprised at some of the things that you can go look and apply for today.
Oh, absolutely. And there are some comments of thanks and appreciation. So a lot of people seem to be have gotten benefit out of this program, expressing it right now. So glad to see that, and thanks everyone for letting us know.
Great, thank you very much.
Yep, terrific. Want to let folks know what's going on next month here at the Breakfast Club of New Jersey. Next month is Alex Freund, career coach Alex Freund, and he will be talking about, so tell me about yourself. That's probably one of the most common interview questions, maybe every interview has that question. And he's going to talk about how do we properly answer that question. So I think that becomes very relevant for all of us as we move forward through the interview process. And then, of course, our good friend, George Pace, he continues to have his weekly live webinars, and they're on Sunday mornings, and it's on Facebook.com/keeppace, Facebook.com/keeppace. So you're welcome to check that out tomorrow morning. And he also has his recorded, so he's got a library of his prior webinars as well. And so that's it for our program, letting you know that we have recorded this program, or reminding you that we have recorded it. We are going to make it available on our group's YouTube channel, so you can just search in YouTube for the Breakfast Club of New Jersey. Our prior several months of videos are there right now. It'll just take us a little time to download this and process it, so you'll be able to watch it again if there's some concepts you need reinforcement. And also, in a moment as we end the meeting, I'm going to keep the session open a little bit so we can have a little bit of free-form virtual networking. I will turn the recording off at that point as well. So anyone who wants to stick around and chat with each other, Lindsley, you're invited to stick around as long as you're able to. So we'll keep that open as well. So I want to thank everybody and for attending. Thank you again to Lindsley for participating and supporting the Breakfast Club. And I hope we all can see you virtually next month right here at the Breakfast Club. Bye, everybody.